connection. Good morning, Nana. Continuation of exercise 5.5 permutations and combinations. Okay, today with continuation of the last ending of the lesson, permutations and combinations, exercise 5.5, last one. Now up to 21 over. Now today we will start 22nd problem. These are conceptual problems. There are m points in a plane, out of which p points are collinear and no three of the points are collinear, and unless all the three are formed from these p points, find the number of different straight lines passing to the pair of distinct points. Second question, triangles formed by joining these points by line segments. So in the plane there are how many points in the plane are given is m points in the plane. In these, p points are collinear. So what is meant by collinear? Collinear nothing but the points lying on the same straight line are called collinear. So out of m points, p points are collinear and no three of the points are collinear. So p points are collinear in the form unless the three form these p points. Find the number of different straight lines passing to the pair of distinct points of m points. And next second question, triangles formed by joining these points by given line segment. So this is the question. So this is completely theoretical question. So that is totally the points are given, m points are given. So m points are given. In these, some points are collinear, that is suppose p points. P points are collinear. So how many straight lines passing to this pair of points? So we can join to form a straight line. So we need 2 points. Straight line means we want to use only by using the 2 points only. So out of in the plane there are m points in the plane. So we construct a straight line means we need 2 points are we need. So from this out of m points we can draw a straight line by how many cases means we are selecting out of m points 2 points are needed. So this can be done in MC2. Why? Because MC2 to form a straight line we need 2 points. Out of m points this can be done in MC2 points. But in these p points are collinear. So the points forming their passing to these p points are 2 at a time. So we get only one line is instead of getting PC2 lines. So that is p points are collinear are there out of m points. So we can draw a MC2 points. That is MC2 points. So MC2 points are straight lines we can form. Out of P points are collinear means we cannot, P points are unless if it is not completely, so it is no three of them are these P points, it cannot be formed a collinear. So that is why we can subtract out of MC2 minus PC2. All will be at, all points are overlapped, then means this all these points overlapped means we can get only one point, one line is we can form. So that is why we can add as P plus 1. So total number of points are in the plane is M. By drawing the straight lines passing to 2 points is MC2, but P of them out of this M points is collinear, so we can get as to PC2 points. Out of in these points overlapping the all points, if you taken the points will be only one, we get a one line. So that is line passing to P points two at a time, then we get only one line. So it is therefore we can by adding this. So number of lines are MC2 minus PC2 plus 1. This is the conceptual question. Out of M points we can draw a straight line means MC2. PR collinear means PC2 points we can get. Out of all these points, anyway we can get a all points to be overlapped, then you get one line is common. So that is why we can by adding this total value. That is therefore number of lines we can form it is MC2 minus PC2 plus 1. Okay, this is the way of writing. Then go to the second one. In this second question, so how many triangles can be drawn? In out of M points we can get how many triangles we can get. So join we have to form a triangle we need 3 points. So out of M points we can draw a MC3 points of triangles. So in these P points are collinear. Suppose collinear means we cannot construct a triangle. So because triangle means non-collinear should be completed, we have to need. If it is the line same point on the line, so we cannot construct a triangle. Out of P points are there, to make a triangle means we can get PC3 points. So P points to form a triangle means by using the collinear points we have. So that is why we can get PC3 points. But we need to number of triangles formed by joining the M points we are asking. So total minus collinear points, then you get MC3 minus PC3 points are number of triangles to be formed by joining the M points. So totally M points are there. To form a triangle means you can get MC3 points. But in these P points are collinear. If the condition to be collinear, we cannot construct a triangle. So that is why we have to eliminate it. Then we can get the value total number of triangles means M total plane points minus collinear point, that is MC3 minus PC3 points. This is the number of triangles to be formed by the joining the M points in the question is given in the plane. So that is the question number 22nd, second one. Next go to the 23rd question. If a set of M parallel lines intersect another set of N parallel lines, find the number of parallelograms formed in this lattice structure. So in the plane we have totally parallel lines are there. So that is suppose this has to M parallel lines. And then another set of parallel lines, that is N parallel lines. So that is taken as suppose this has to N parallel lines. That is N parallel lines. Then you can find the number of parallelograms formed in this lattice structure. So parallelogram means we need to both 2 points, that is opposite sides to be equal and parallel. So first we need to out of M points we have to any 2 lines we can select by M parallel lines. This can be done in MC2 ways. So 2 points we need out of M points, M lines. Then you construct the MC2 lines. MC2 ways we can select to form a parallelogram. And the second set of N another parallel lines. Second set of N another parallel lines. To form a parallelogram, we need 2 lines. So that is in this way we can construct by selection of n things from out of 2 points, that is NC2 ways. So total altogether means then you get the parallelogram. Altogether means you have to multiply anywhere. So work 1 is MC2 and work 2 is NC2. Then you can multiply. Okay. So there are m parallel lines to form a 2 parallelogram. We need 2 lines. Any 2 lines. So out of m parallel lines, we can select 2 lines in the MC2 ways. Another set of n parallel lines we can select to form a parallelogram. This can be done in NC2 ways. Therefore, total number of parallelograms formed is MC2 into NC2 ways. This is the number of parallelograms formed in this lattice structure. Out of m lines, we can select to form a parallelogram MC2. Another set of n parallel lines. To form a parallelogram, we need 2 points. That is in the so that is to form parallelogram, that means NC2 ways. Therefore, the number of parallelograms to be formed is MC2 into NC2 ways. This is the question number 23rd. Then go to 24th question. If there are 5 alike pens, 6 alike pencils, 7 alike erasers, find the number of ways of selecting any number of, in the brackets, 1 or more things out of them. So all are alike things are given. So in these alike things we have 5 alike pens, 6 alike pencils and 7 alike erasers. Find the number of ways to select any number things out of them. So the selection must be either from the pens and pencils and select erasers. So that is by number of ways. Any number of times we can use out of things out of them is the number of ways we have to find. So from first alike pencils we have to take. Alike pens. 5 pens to be selected. Either our wish we can select as 0 pens, or another way is one pen can be selected, or two pens can be selected, either 3 pens can be selected, so on 4 pens to be selected, and either 5 pens to be selected. So total number of ways are how many here? 1, 2, 3, 4, 5, 6. So this is equal to 6 ways. Either you cannot name any number means you have to take it as select as 0 pens also it is a one way. If you don't want it, by using you can select as 0 pens, or in one way 1 pen we have to take, or second 2 pens, or 3 pens, or 4 pens, or 5 pens. Then we have total, this can be selected in how many ways means 6 ways, and similarly 6 alike pencils also. 6 alike pencils are there. So it can be selected. Then we have to select either 0 pencils or 1 pencil or 2 pencils, so that up to 6 pencils. This total things will be 7 ways. And similarly 7 erasers are there. So this can be done in 0 way, 1 way, 0 eraser and 1 eraser, 2 eraser, totally 8 ways will. So therefore the number of ways of selecting any number are 1 or more things. Taking 1 or more means you have to subtract in this by 1. So P plus 1 into Q plus 1 into R plus 1 minus 1. This is the formula. So then substitute, then you get has here 335 ways. That is the formula for number of ways of selecting any number of R 1 or more things is in the form P plus 1, Q plus 1, R plus 1 minus 1. So that is 5 plus 1. 5 pens are there, 6 pencils are there, 7 erasers are there. From this minus 1. So that is why we can get 0, nothing but 0 selection means you have to take subtract all those, we have to select one way. So that is why we write here minus 1. So total value becomes to 335 ways. So that is the question number 24. Then go to the 25 question. To pass an examination, a student has to pass in each of the 3 papers. In how many ways can a student fail in the examination? So total question is given that number of papers are there, 3 papers. To write an exam, to pass an examination, a student has to pass in each 3 papers. But in the question is given that In how many ways the student can he fail? In how many ways can he fail means, so number of, first we have total how many number of conditions, choices are there to pass an examination, we have to write. So number of papers are here, 3 papers, and the choices can a student write an examination are first paper in the form pass, and second paper also pass, and third paper also pass. The total choices we have to write by using the 3 paper. This is called paper 1, paper 2, paper 3. PFP means pass, P equal to nothing but P equal to pass, and F means fail. So 3 papers we have to, one choice is all papers should be passed, and another first paper, second paper, and fail. Like this totally you get 8 choices there. This is the number of choices that a student can write an examination. So but in the question it is given in how many ways can student can be failed. So fail in the examination means total ways minus the passing choices. So in these, this can be fail. This can be fail. This is fail. This is one paper fail means total result values becomes to fail. This fail, this total is well except PPP. That means all papers should be passed. Then the student can pass to pass the examination. The remaining choice are only one choice is to pass, then total choice is 8. So 8 minus 1 equal to 7 ways. So number of ways equal to 7 ways. This is the how many ways can a student fail in the examination is 7 ways. Total ways is 8. In this pass to be in this a student is to be 1 way, then you get 7 ways. This is the question number 25. Then go to question number 26. Find the number of positive integral divisors of 1080. So that is the concept of positive divisors of 1080 is asking. So 1080 means first you have to take the prime number, prime factorization. So any natural, this is a general formation. Any natural number n can be, n is capital N here, any number always expressed as the product of prime numbers, then n equal to write as p1 to the power of alpha 1, p2 to the power of alpha 2, p3 power alpha 3, so on, pr power alpha r, where p means p1, p2, p3 means prime numbers, alpha 1, alpha 2, alpha 3 means the prime number repeated times. Alpha 1 is repeated as alpha 1 times, p2 number repeated as alpha 2 times, P3 number is repeated as alpha 3 times. Then we get PR to the power of alpha to the power of r. The total number of divisors are this. So 1080 means by taking LCM, you can get 1080 by taking LCM 2 5s, 2 4s. So that is 2 2s, and then you get 3 9s, and then also 3 30s, and this is prime factorization, then 5 2s and 2 1s. That means it is 1, that is 2 cube into 3 cube into 5 to the power of 1. So any prime number can be by always expressed as a product of prime numbers we have to take. So this can be in the prime numbers is 2 cube into 3 cube into 5 to the power of 1. So then we can write the number of divisors are power means 2 repeated as 3 times, 3 repeated as 3 times, and 5 repeated only 1 time. Number of divisors means adding the repeated terms. 3 plus 1, this is the P1 here. This is P alpha 1. This is as to alpha 2. Nothing, 1 means alpha 3. So alpha 1 plus 1, alpha 2 plus 1, alpha 3 plus 1. Then you get 32 ways. This is the number of positive integral divisors of 1080. The only formula is alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1. So on alpha r plus 1. So in this way, by doing the prime factorization, then you get the as expressed as product of prime numbers, product of prime numbers multiplied, and then you get repeated terms should be adding 1 and then multiply. Alpha 1 plus 1 means 3 plus 1, and this is 3 plus 1, and this is 1 plus 1. Then you get 32 ways. This is the question number 26. Now the VSQ is over. Then go to the short answer type questions. So that is now short answers, remaining questions are VSQs are over. Then go to the short answer type question. If a set A has 8 elements, if a set A has 8 elements, find the number of subsets of A with at least 6 elements. A set has 8 elements is given. Find the number of subsets of A with at least 6 elements. So at least 6 elements means that it may contain 6 elements or 7 elements. Maximum is we have 8 elements means we have to get 6 or 7 or 8 elements. The set A should contain at least 6 elements means that it may contain 6 or 7 or 8 elements. Therefore, the number of subsets of A with exactly 6 elements is 8C6. Out of 8 elements, we have to select 6 elements, that is 8C6. Out of 8 elements, we have to select 7 elements, that is 8C7. And exactly 8 elements means 8C8. Therefore, the number of subsets of A with at least 6 elements is 8C6 plus 8C7 plus 8C8. This is nothing but 37 ways. Total ways are 37. This is a question number, short answer type, first question. And then in the second question is given, if a set A has 12 elements, find the number of subsets of A having 4 elements, at least 3 elements, at most 3 elements. Number of elements in set A equal to 12. Therefore, the number of subsets of A exactly 4 elements is, out of 12 we can select as 4 elements, that is 12C 4 ways. So 12 into 11 into 10 into 9 by 4, 3, 2, 1. That is the formula for NCR, product of the first any natural numbers decreasing by n. But here n equal to 12 up to right up to 12 into 11 into 10 into 9 divided by 4 into 3 into 2 into 1. Then you get 495. That is number of subsets with A exactly 4 elements is 12C4. In the second question, at least 3 elements. So, the set A contain at least 3 elements means out of 12 elements, that means it may contain exactly 0 elements and 1 element and 2 elements. At least 3 elements means. So, that is by 0 elements we can get you can get 12C0, but I am doing here actually at least means you have to select either 4 or 5 or 6 or 7 or 8 or 9 or 10. But I am doing here by subtracting total subsets minus these elements. Then you get also the set at least containing 3 elements also you can get. That is, the set A contain at least 3 elements means it may contain exactly 0 elements or 1 element or lesser to value, total minus this value I have to take. So, number of elements, subsets of A with exactly 0 elements, nothing but that is 12C0 selections and 12C1 by element of 1 taking exactly 1 element and exactly 2 elements means 12C2. Therefore, the total number of subsets of A formed is 2 to the power of 12. Then I am doing here number of subsets of A with at least 3 elements means total number of subsets minus number of subsets contain 0 or 1 or 2 elements. I am not doing like that in the previous question like that, but here I am with at least 3 elements means the set may contain either 4 or 5 or 6 or 7 or 8 or 9 or 10 or 11 or 12. So that will be lengthy calculation. That is why I am taking total number of elements minus the subset number of subsets contain 0 or 1 or 2 elements. That is total number of subsets are 2 to the power of 12 minus 12C0 plus 12C1 plus 12C2. That is 12C0 is 1, 12C1 is 12, 12C2 is 12 into 11 by 2 into 1, that is 66. This total value is 79, then you get 4017 ways. So that is the question number, at least the set number of subsets contain A by using the 12 elements. Now third question is, given at most 3 elements. The difference between at least and at most we have to learn. At least means up to, right up to 3 to 4 to 12. But here at most means the set which may contain 0 or 1 or 2 elements. So that is number of subsets of A exactly 0 elements is in the form 12C0 and number of subsets of A exactly 1 element is 12C1 and next exactly 2 elements is 12C2, exactly 3 elements is 12C3. Therefore, the number of subsets of A with at least 3 elements is 12C0 plus 12C1 plus 12C2 plus 12C3. Then you get 299. This is the value for a number of subsets containing the at least 3 elements. Next, third question. In the short answer type, find the number of ways of forming a committee of 4 members out of 6 boys and 4 girls such that at least one girl in the committee. At least one girl in the committee. So, number of forming a committee of 4 members we have to find committee members out of 6 boys and 4 girls. At least one girl in the committee means the number of ways of forming a committee of 4 members out of 10 members is 10C4, and I am doing here the number of committee having no girl is 6C4. Why? Because we are selecting all 4 members from the boys. That means at least one girl means we are subtracting. Having no girls in the committee also same thing. Or else containing the one girl in the committee, 2 girls in the committee, 3 girls in the committee, 4 girls in the committee. That way also you have to do. But in the simplest way is total ways minus having no girls also you can get the at least one girl. This is also another way. If you wanted to do at least one girl means the committee contain at least one girl, 2 girls, 3 girls or 4 girls. That is also another way. But I am doing the total ways minus having no girls in the committee. Total ways by selecting the out of 10 members, we are selecting 4 pair committee member, that is 10C4 ways. And having no girls in the committee can be done in 6C4 ways. Then you get the value 10C4 means 10 into 9 into 8 into 7 by 4, 3, 2, 1 minus 6C4 nothing but 6C2. Why? Because since NCR equal to NCN minus R, 6C4 nothing but 6C2 value. That is 6 into 5 by 2 into 1. Then get 210 minus 15. Then you get 195. This is the question number third question. Next, go to the fourth question. Most important problem. This is fourth question, fifth and sixth question. Find the number of ways of selecting a cricket team of 11 players from the 7 batsmen and 6 bowlers such that there will be at least 5 bowlers in the team. So, to form a committee team of cricket players, in the team is contain 11 players, but in the 11 players, 7 batsmen and 6 bowlers are such that there will be at least 5 bowlers in the team. Compulsory must and should have that 5 bowlers in the team. That is, number of batsmen here 7 and number of bowlers is 6 and total number of players in the cricket team is 11. But in the question is given that the condition to be applied, there will be at least 5 bowlers. At least 5 bowlers in the team. Team may contain total players are 11. So that is the number of choices to we have to write. So number of batsmen here 7, number of bowlers is 6, total players are 11. Now out of 7 batsmen, first we write here batsmen and then bowlers. Bowlers here maximum 6, batsman maximum is 7. This is number of selections, number of ways. So type 1, type 2 we are getting. So the should be first you take at least 5 bowlers in the team means starting, at least 5 means starting with 5. So starting with 5 means you can get totally numbers to be playing a cricket game is 11. So 11 minus 5, then you get batsman is choice is 6 ways. At least 5 means you may contain 6 bowlers also is another way. So 6 means 11 minus 6 is then you get the batsman, that is 5. It's suppose take the 7 bowlers also, but we are no having the bowlers maximum is 6. Then you get two ways only for this one. So if it is 7, 8, 9 total, up to 11 will be choices will be there, but the number of bowlers maximum is 6. Therefore 6 starting with 5. Starting with 5 and maximum is 6. If it is 6, 5 bowlers are taken, then you get the selection of batsmen are 6. Why? Because total becomes to 11. 6 plus 5, 11. And if it is taken as 6 bowlers, then you get here also 5. Total things are 11. So total players in the team is 11. So it will be over. Out of 7 batsmen, we are selecting 6 batsmen. This can be done in 7C6 ways. And 6 bowlers, out of 6 bowlers, we are selecting 5 bowlers, that is 6C5 ways. So 7C6 into 6C5, 7C6 nothing but 7C1. Why? Because NCR equal to NCN minus R, 7C1. 7C1 nothing but 7. And 6C5 nothing but 6C1. 6C1 nothing but 6. 7 into 6 is 42. And the type 2 is 5. Out of 7, we are selecting 5 bowlers, 5 batsmen, that is 7C5 ways, and 6 bowlers, we are selecting 6 members, that is 6C6. Total value becomes to 721 into 1, that is 21 ways. So this is the total ways to be we can add. Therefore, the number of ways of selecting a cricket team is 42 plus 21, that is 63 ways. So the condition to be applied, number of bowlers must be 5, 6 bowlers. So with such that there will be at least 5 bowlers, nothing but we have to select here 5 or 6, and other way 6 or 5. Maybe 7 or but maximum is here 6 only. So don't take the maximum. This total type 1 and type 2 we can get. Then it's calculation, then add the values, then you get the total at least 5 bowlers in the team. The number of ways you can get, that is 63 ways. This is the way of writing. Then go to the similar question, question number 5. Find the number of ways of forming a committee of 5 members of 6 out of 6 Indians and 5 Americans, so that always the Indians will be majority in the committee. So committee members totally are 5, maximum number of Indians are 6 and Americans are 5. But in the question is given always the Indians will be majority in the committee. So let us start with maximum number is 5. So the committee means you complete the committee members should be there by 5. So if we are selecting out of Indians 6, we can start with 5. The Americans should not be taken, that is 0 ways. And next type 2 is if suppose selecting only 4 members out of 6, then you get Americans to be choice is only 1 day. Why? Because the total number of committee members should be 5. If it is taken as 4 here, then you get from the Americans by only one person. And then go to the Indians will be 3 and the Americans should be 2. If it is, we can take it as 4, but here goes to so 6 and 3, 4, 5. Next here 2, and then go to here right as 2 means record here 3. Then the majority of the Americans should be over. So that is why this is on the type 1, type 2, type 3 is necessary. That is enough. If it is we are selecting 2 ways, here goes to 4 ways, 3 ways. Now the condition is not satisfied. The Indians will be majority in the committee. Therefore, this type 3 will be closed up to this. 504132 ways. That is the 3 types. Out of 6 Indians, we are selecting 5 means 6C5. 5 we are selecting out of 0, nothing means 5C0. 6 Indians from out of 4 means 6C4. And 5 Americans in the 1 means 5C1. And here 6 out of 3 means 6C3. And here 5C2. That is 675 total calculation. Then you get 281 ways by adding 6 plus 75 plus 200. This is the way of number of ways of forming a committee of 5 members in the committee. That is 281 ways. Next, go to the sixth question. A candidate is required to answer 6 out of 10 questions, which are divided into 2 groups, A and B, each containing 5 questions. He is not permitted to attempt more than 4 questions from either group. Find the number of different ways in which the candidate can choose the 6 questions. So the candidate is required to answer is 6 out of 7 questions. So we have to select the number of ways in which divided into two groups A and B. That is each section containing 5 questions. He is not permitted to attempt more than 4 questions from either group. Find the number of different ways in which candidate can choose 6 questions. Maximum to be selecting ways is 6. Choose to 6 questions, but in the 2 groups are divided. So write a tabular form as number of total questions are 10, number of groups are 2, that is A and B. Section A, section B. Here write a number of ways. How many ways you can get? Type 1, type 2, type 3. Total choosing 6 questions from, suppose we have taken some section A is 4. Why? Because he is not permitted to attempt more than 4. So more than 4 means you should lesser to 4 number. 4 ways, 3 ways, 2 ways. Obviously section A 4 questions are chosen now. Then we can select section B as only 2 questions. Why? Because total becomes to 6 questions we can choose. First section may be maximum 4 questions we have selected that person. Then you get section B out of only 2 questions we have to select. And if it is 3 questions, then you get section B also 3 questions. If it is 2 questions, then you get 4. Here you get 1 and here also maximum not be. The maximum should not be take it as 4 question. That is why you should not take the type 4. Then you get here 5. So that is more than. So that is no way. That is only 3 choices are there. From this 5 question we are selecting 5C4 and this 5C2 and this is 5C3 and 5C3 and this is 5C2 and this is 5C4. By calculating you can get 200 ways. This is the question number 6. And the last question is find the number of ways of giving away the 4 similar coins to 5 boys. If each boy can be given any number less than or equal to 4 of coins. So this is a fully objective question. Just a simple logic thing you have to write. Number of ways of giving away 4 similar coins to 5 boys. So coins are lesser, boys are more. So the condition is given that if each boy can be given any number of less than or equal to 4. So less than or equal to 4 of coins. So that is why we are writing here the 4 similar coins can be divided into 2 different groups as follows. The first one is we are selecting, I am doing work 1, we are doing selection from the boys. And let us take the W2 means selection of coins from a bag. Work 1 is selection from a boys and selection of the coins from a bag. Here number of boys are 5, number of girls, number of coins are 4. In this way I am doing the table frame. Suppose the coins, serial numbers, coins and number of boys and number of ways I am writing. So there is a choice to write the 4 coins as to choice here and number of boys choice are here and total value becomes like this. Suppose the 4 coins I am doing in the one bag, from the bag I am let it be and all coins in this bag, that is 4 coins. 4 coins are there in this bag, but I am distributing out of 5 boys. First one I am selecting only one boy. There is first choice, that is out of 5 boys can be given to the one boy. So this can be done in out of 5 selection of one boy means it can be done in 5C1 ways. So next another 2 is W2. W2 we have taken the selection of the coins from the bags. How many ways we can select? Only one way. Why? Because the person is only, so 4 coins to be selected. This is the one way. Then 5C1 into 1, that is 5 ways. And the next choice is it should be total coins are 4. This will be distributed as 1 coin in the first bag, another way, and 3 coins in the second bag. So two choices are there. That is when we are selecting the 2 boys. That is what one W1 is out of 5 boys. Selecting the 2 boys in this way is 2 ways. That is 5C2 ways. And next work 2 is when 2 boys are selected, the ways is 2 ways. Why? Because 2 ways. If it is boy chosen as this second bag, this is one way, and boy 2 as select, this is another way. This is the one way. And boy 1 choose to another way is this boy 1 also take it as 1 coin in the bag and boy 2 is take it as 3 coin. This can be total thing in how many ways means 2 ways. So 2 ways into 5C2. Then W1 into W2, that is 2 into 5C2. And another choice of the coins is totally 4 coins distributed as here 4 coins in the one bag and here 1 coin and 3. And here 2 coins and 2 coins. 2 boys are there. I am doing the 2 ways. That is 2 boys we are selecting. 2 boys out of 5 means we can W1 means we can write as 5C2 and W2 is one way. Why? Because the 2 boys should be taken. This bag also one way. This one anything way only one way. There is no difference between them. So that is why we are writing. So one way. So W1 into W2 is 5C2 ways. In the coins to be distributed as another 3 bags, that is 1, 2 and this is 1. We can 3 bags are there. So out of 5 boys selecting the 3 boys can be done in 5C3 and W2 means selection of the bags of the coins, that is first person, second person and third person. So if it is a choice to first person select is 1 coin, second person select is 2 coins and third person is 1 coin. And another by the choice is 2 coins you have to select and second person is 1 coin, third person is 1. Another third condition is 1, 1, 2. This is totally 3 ways to the selection of the coins from a bag. Then W1 into W2 means 3 into 3 ways into 5C3. And the last condition is the coins to be distributed, that is 1 bag into the 1 coin, 1 coin, 1 coin, 1 coin, totally 4 coins. To be selected is out of orders we are calling from any 4 boys. This can be done in work 1 is 5C4 and work 2 is one way. Right? Why? Because all are same coins. So coin selection is same. Out of this coin selected, this is the one way. And anyway, 4 bars can be chosen as only one way. So that is 5c4 into 1. That is 5c4 into 1 means 5c4. Then the total value is number of ways can be student giving up to 5 coins is 5c1 plus 2 into 5c2 plus 5c2 and 2 into 5c3 plus 5c4. Then you get total value becomes to 70 ways. This is up to permutations and combinations is over. So then we will start another lesson tomorrow. So practice all those videos and practice again so many times. See all of you for a practice more, Nana. Okay, thank you.